Okay, so we're talking about scope of inference, and we want to describe the scope of inference that's appropriate in a particular study that we're doing. And there's two types of inference that we really talk about. And when we say inference, it means we're taking information about a small group of people and we're inferring it to be true about the entire population. And so that would be our first scope of inference here, is if we want to do inference about a population. Okay, inference about a population. So we would do that when we do a survey. We ask people questions. We maybe do a presidential election, and we ask the people, who are you voting for? And if in our sample 60% of the people say they're voting for candidate A, then we infer from our sample, as long as it's well designed, that 60% of the people in the population are also voting for candidate A. That's inference about a population. When you take information from a small group, a sample, and then infer it to be true about the entire population. The second type is inference about cause and effect. Okay, does one thing cause another? Usually we do this, certainly when we have experiments where we look at medications for, treating cancer or some other disease. What we want to know is if the patient gets better after we give them medicine, is it actually the medicine that's causing them to get better? So we would design an experiment with a placebo and a control group to see that the medicine is actually the cause of the person getting better. Now, when we can do this scope of inference is a couple times here. Okay, first of all, we can do scope of inference. We have to have a couple things met here. And we ask these questions. Were individuals randomly selected? Okay, did we randomly select people from the population to be in our study or whatever it is? There are two possible things. Either it's yes or it's a big no. Okay. The other question here is, were individuals randomly assigned to groups? And again, it could be yes or it could be no. Depending on our answer to those two questions, tells us what we can do our inference about. So if individuals were randomly selected, okay, then inference about population is allowed. In whether or not they were assigned to groups doesn't matter. Okay? And if they were not randomly selected from the population, then we cannot infer about the population. That's a no. Okay. That's supposed to be short for population there, no. Now, if they were randomly assigned to groups, then inference about cause and effect is allowed. So in this column, inference about cause and effect is allowed. And if the answer is no, they were not randomly assigned to groups, then inference about is not allowed. Okay. Okay, now there's some of these places we just never like to spend our time. Number one is this one right here. We don't want to spend our time when we can't do inference about population or do inference about cause and effect. That doesn't help us any. There are certain things, certain times where they are there. So for example, if we did a convenience sample, where we sample people that show up conveniently. They show up to the mall. So we only talk about people at the mall. Or our other type, our voluntary response sample. Okay, those we cannot infer anything about the population or about cause and effect from those things because they're flawed ways of gathering data. Okay? We also don't spend a lot of time here in the yes. Sometimes we can, it is possible, but oftentimes, so for surveys, we don't worry about cause and effect. And in a survey, we're just asking people questions, and so surveys are often here, where we ask people questions. We can't really infer about cause and effect because we're not assigning people to groups, we're not assigning treatments, anything like that. There's nothing for us to, we can infer about the greater population, but we can't really infer about cause and effect. And experiments almost always go here. It doesn't have to be true. Some experiments can go up here in the yes category, but experiments most of them sit here because we can't really infer about the larger population because we're not often randomly selecting people from the population. For example, if we want to test a cancer drug and see how it cures cancer, we don't want to randomly select people from the population for that. We want people who have cancer so that we can see if it does indeed cure cancer. That's what we're after. So we would not randomly select people to be in our experiment. We would take people that fit a certain condition. They have cancer, they have a brain tumor, they have something. Okay? So while there is time where we spend up here where we can infer about both. But a lot of times experiments are here. You cannot infer about the population, but you can infer about cause and effect. And surveys are often over here where you can infer about the population, but you cannot infer about cause and effect. Okay. If you want to read more on this, it's on page 266. And page 267 in your book here. Okay. So let's look at some of these things and see what we get here. All right, do calories matter? Does including the number of calories on a menu encourage diners to make healthier choices? That's a good question. Two AP statistics students designed a study to find out. They randomly assigned students to look at one of two different menus and indicate what they would order if they dined at the restaurant. One of the menus listed the number of calories for each item and the other menu did not. The result? No significant difference in the average number of calories ordered. The two students speculated that there wasn't a difference because the students weren't actually at a restaurant and didn't get to eat the food they ordered. In other words, the experiment suffered from a lack of realism. That may or may not be, and we don't know. But they would have been able to refer, okay, they wanted to infer about cause and effect. They wanted to infer about cause and effect that having the menus with the calories on it would have caused people to order lower calorie things. And they certainly didn't get that result. And maybe because they didn't get that result, they were looking for a reason why. But I bet there probably is no significant difference, to be honest with you, in that one. All right. Let's look at the last thing here. Do tanning beds cause cancer? Doctors have noticed that people who frequently visit tanning salons are at much greater risk for skin cancer. But are tanning beds the cause? Could the association be due to another variable, such as sun exposure? After all, people who like to tan indoors also probably like to tan outdoors. An experiment would help settle this question, but forcing people to use tanning beds to see if they get skin cancer is not ethical. Well, that's what they were talking about, the ethics of doing certain things. We can't just force people you know, drink poison because we want to see what it does to them. We can't do things like that. That's what we're talking about, the ethics.